Hello, this is the carbon sequestration group from Dr. Zelisko's ENGI1331 class. Our topic covers how to develop carbon sequestration methods that will sequester carbon from the atmosphere and store it safely away in an effective manner. To be more precise, however, the term carbon sequestration is used to describe both natural and deliberate processes by which carbon dioxide is either removed from the atmosphere or diverted from emission sources and stored in the ocean, terrestrial environments, and geologic formations. It's been proven by scientists and engineers alike that the accumulation of carbon in our atmosphere as a result of the sun's solar energy has led to more recurrent natural disasters such as hurricanes and the melting of icebergs, among many other major and dangerous natural disasters. Now, with this program, we intend to create a tool that will help these engineers compare different carbon sequestration methods and evaluate the most effective. In other words, this code will help the user visualize plots, images, and understand how each carbon sequestration works, and possibly be a forerunner for future programs that will help these engineers conclude the most effective method and apply it. For our algorithm, we decided to make a flow map. At the beginning, we started using our housekeeping commands. Then we loaded all the data and all the images using the XLS read function and the AM read function. After that, we use a menu function to ask the user which method of the three that we have they would like to review. The three methods are carbon capture and storage, biological sequestration, and marine carbon sequestration. After the user selects one of them, we're gonna give an fprintf command to display information, pros and cons about that topic. After that, we're gonna display an image showing the three images of the topics, and we're gonna highlight and filter the one that they choose. After that, we're gonna ask the user if they would like to review another method. If they say yes, we're gonna go back to the first menu, but now it's gonna say already chosen for the ones that they have chosen before. If they select the same one, the one that says already chosen, we're gonna display a warning message asking them to select another one until they do that. Then we're gonna go to the same process, the fprintf, the images, and we're gonna ask them again. The maximum times they can do that is 3, which are the 3 methods that we have. After that, we're gonna display a warning message saying that they already choose all the methods, and we're gonna give them a final plot with the 3 methods comparing the effectiveness of all of them. We're gonna do the graph for each of them if they only do 1 or 2 or 3, depending on how many they select.
Code again for several methods. For our outputs, we will be displayed an image of our selected method outlined in a red box, and information about our chosen method, and a graph, carbon captured versus time. When we first run our code, we will be prompted with a menu. This menu will ask us what method we would like to learn more about. The 3 options are carbon capture and storage, biological sequestration, and marine carbon sequestration. For this case, we will select carbon capture and storage. Once we select it, we will then be displayed information about carbon capture and storage in a short paragraph form. This paragraph will contain information about what carbon capture and storage is and how it works. It will also display pros and cons of this method. After this information is displayed, we will be prompted with a large image. This large image will be composed of 3 smaller images, each image corresponding to one of the methods provided. Now only the method that we have chosen will be in color scale and outlined in a red box. The other methods will be shown in a black and white scale. In this case, only carbon capture and storage image will be shown in color and outlined in a red box. Upon further examination of this image, we can learn more information about our method. After we are done reviewing this image, we will be asked if we would like to repeat the code again. For this option, we will hit no. We will then be displayed a plot comparing the effectiveness of only the methods we have reviewed. In this case, it would be a single line because we have only reviewed one case.
For test case 2, we review all 3 methods. As in the first test case, a menu appears so that the user can select one of the 3 sequestration methods. Once the user selects a method, an image with pictures representing each method appears. The picture representing the chosen method appears with a red border, while the other 2 images are set to a grayscale. Information on the chosen method will appear on the command window. This information includes pros, cons, and a brief description. The user gets the choice to run the code again, and in this case, the user does. We have included data validation so that the user is not allowed to choose a method twice. Hence, the user must select from the remaining methods. Once the user finishes reviewing all methods, a carbon captured versus time gap appears. A statement appears on the command window expressing which of the methods is best according to the information we have gathered. In this test case, the best sequestration method is marine sequestration because it's attainable, cost-reducing, and effective.
In conclusion, this program could be used as a tool to compare and determine the most effective carbon sequestration methods using MATLAB R2017. With the increasing concerns of global warming disasters, this program could be a promising tool that could use collected data to visualize theoretical outcomes and apply the best method. Updating it simply requires taking verified data and typing it into an Excel file and incorporating it into our code. Having minimum access to considerable verified data led us to a slightly different path in our program, but allowed us to create a tool that will help these engineers predict the most effective carbon sequestration method. Thank you.